the country. So I once again welcome all our resource persons, all our participants to this 3-day training program. I hope this
Good evening to one and all present here. We welcome you all to the 3-day online training program on infrastructure, health mapping standards, and retrofitting of built-up facilities. This online training program is jointly organized by Civil Engineering and Construction Review and National Institute of Disaster Management, Ministry of Home Affairs, Government of India, powered by Revered Media. Welcoming our distinguished guests, eminent dignitaries, and speakers. We are honored to welcome our chief guest of the day, Shri Taj Hassan, IPS, Executive Director, Additional Charge, NIDM, Government of India. Shri Taj Hassan, a 1987 batch IPS officer of Arunachal Pradesh, Goa, Mizoram, Union Territory, Kedar, was appointed as the Director General of Fire Services, Civil Defense, and Home Guards as per MHA's proposal. Mr. Hassan also served as the Special Commissioner of Police Traffic. He has also been the Chief Spokesperson of Delhi Police, a first of its kind. He has also handled key assignments in the national capital as a Special Commissioner, Crime. He had earlier served as the Chief of the Traffic Department of Delhi Police and as Joint Commissioner of Security Unit, among other important positions. He has also worked in the Narcotics Control Bureau as a Deputy Director General. Unfortunately, Shri Hassan could not be a part of today's conference. He sends his best wishes for the session. Welcoming our special guest for the day, Dr. K.M. Soni, former Additional Director General, Central Public Work Department. With a PhD from IIT in Geotechnical Engineering, BE Civil and MTech from Manik Bhopal, MBA from IGNOU and Rural Environmental Management Certificate courses from University of Bangor, UK. He, after joining Central Engineering Services Group A in 1983, worked in CPWD and retired as Additional Director General in July 2019 with rich experience in planning, construction, and maintenance. He has been instrumental in execution of projects and bringing out various publications. He has also published more than 150 technical papers and received many awards, including 2 DG CPWD medals, CIDC Public Officer Trophy, CIDC Technologist Award, IBC Best Project Trophies, 6 IBC Best Paper medals, and many other condemnation certificate. He has been the member of reputed bodies like Member of Leadership Excellence of Harvard Square, Senior Professional Engineer of Engineering Council of India, Fellow of the Institution of Engineers India, to name a few. Presently, he is Resource Faculty of BMTPS on Innovative Construction Technologies, Consultant to ITPO, Expert Advisor for BRSA, DRB Member of NHAI, and Arbiter of CPWD. We welcome you, sir. Welcoming our next special guest, Engineer Sanjeev Kumar, Director, IAHE, Ministry of Road Transport and Highways, India. Engineer Sanjeev Kumar is the Chief Engineer of RAMS and IBMS Ministry of Road Transport and Highway. At present, he is the Director of Indian Academy of Highway Engineer. He specializes in road asset management systems and Indian bridge management systems and road safety. We welcome you, sir. We also welcome Professor Chandan Ghosh, Head Resilient Infrastructure Division, NIDM, Government of India, Dr. Bishwajit Bhattacharjee, Emeritus Professor, Department of Civil Engineering, IIT Delhi, and Mr. Manish Bharti, Chief Executive Officer, Cortex Construction Solutions Private Limited. We will present a brief introduction of the speakers before the presentation, post the inaugural session. Now I request Dr. Chandan Ghosh to start today's program with his opening remarks. Over to you, sir.
Good afternoon for this important meeting, online meeting, of course, on a special topic on infrastructure health mapping standards and, of course, retrofitting performance. And we have been planning this with civil engineering and construction review, which is known for more than 35 years in our construction and professional domain, and especially in civil engineering. And this is the first such program that we have taken up. And in fact, NIDM's mission is in disaster management, but while mitigation aspects are looked into, we have to look at the professional that who are working in various facets of development. And the main motive behind such kind of program with CE&CR is to get that what is going on across the country and what are the standards being made available. Also that to see that while we construct building, what kind of safety perspectives that taken from the code and from our experience and what is the design being made, and how design is being interpreted on the ground, and what are the constructions quality being monitored during constructions, and what kind of performance that they are doing. And these things, of course, in our life as a civil engineer, the day we become graduate, we become very much evolved and connected to such aspects. Not only that, that construction and performance, but also we have to look at when something has failed or failure is there, deterioration is occurring. Then again, it is that civil engineer and these professional agencies that have to come forward. The whole gamut of taking up this 3 days program, each day around 2.5 to 3 hours, is to encompass this 3 aspects. One is about the tools and technique, or how to do the health checkup of the building. For that, many agencies are there in our country. Dr. K.M. Soni is our he is having a lifelong experience, especially after his joining to CPWD, with lots of publication, manual guidelines that CPWD has been making vis-a-vis with Bureau of Indian Standards, that especially in earthquake or various other more than 1900 codes are there, and codes are getting vetted and codes are getting updated with the experts available in the country and abroad. So, recent upgradation of National Building Code means recent means 2016 has got 2 more chapters, especially on the construction management aspects. So in that case, we have to see now what are the standards that are available and what kind of methodology being followed. Other countries, that what kind of professional involvements are there. So like American Society of Civil Engineers, they have been rating their structure since 1988. Every 3 to 4 years, they bring out a report that what is the grading, like we grade our students in school or colleges, A, B, C, D. And so 2021 report has come up. And based on that, US government has earmarked $1.2 trillion in November 2021. Now, thing is, where we are going to look forward from the experts, each day 3 presentations are there. And from each of the presentation have been arranged in such a way that we can look at that what are the health checkup of built-up facilities that we look into. Then what are the tools and technique available in the country and also abroad, and who are the market players or who are the agencies and experts working. We have got experts from that area, and also that what are the performance of retrofitted facilities. There are few buildings that retrofitted. In fact, in our country, retrofitting of the Bhuj hospital after 2001 earthquake, that is the first example. After that, many such base isolated buildings are coming up in the country, but still it is not yet made popular because not many examples or encouragements are there to take up such kind of projects. But we have got that experts from that area also, which you will come to know tomorrow and day after tomorrow. And as far as NIDM's role in disaster management, we have been conducting a series of training programs and capacity building and taking up many projects now from the various line ministry, especially making a disaster management plan for, say, Ministry of Agriculture, Ministry of Climate Change, then Forest and Climate, Ministry of Climate Change, and then also like Ministry of Home Affairs also want that plan to be made. In fact, CPWD also has been asking us to join their team to do the disaster management plan for the 450 plus facilities across the country, which is still the file has come again to us to have a meeting with the CPWD chief engineer, which got recently changed, the chief engineer who sent us the letter. So most probably within a day or two, we are going to meet about the and discussing about the terms of reference that which are given to us. About 9 terms of reference are given. I think Dr. Soni is aware of while he was there as a ADM of ADG rather of CPWD in 2019. Will take care of that part, and in fact calling over here with Sanjay Kumarji from IAHE is that it is based on our meeting, that first meeting that we held on 16th of this month, and the kind of outline that he is concerned with being in the position taking up the national highway and number of bridges that which is to be mapped. So it is very, very welcome meeting. I would say that having you, sir, over here to address this occasion, that what are the importance of mapping and setting the standards, and what are the formats to be followed, and vis-a-vis using what are the online or available tools that which are, whether it is GIS, web GIS, and then mapping of the facilities by drone now, just like honeybees are making their own things. So drones are being now designed in such a way that they go around towers and nut and bolts and cracks and everything, so that we get the more specific information, images about the bridges or infrastructures, both inside and outside, and making as-built drawing. So a lot of know-how software part of this have been developed, but we as a professional civil engineer now, we have to see that what this mapping, like CT scan, based on the CT scan or whole body scan, doctors decide that what kind of operation to be required. So a time has come now to have a synchronization and synergy of both surveying and mapping tools, as well as decision making, diagnostics, and then doing the real surgery work in the name of retrofitting. So I would say that thank you very much for gracing this occasion. Welcome to this first day of the 3 days online program.
Thank you, sir. Now I request Engineer Sanjeev Kumar to deliver the special address. Over to you, sir.
Good afternoon, everyone. Dr. K.M. Soni, former Additional Director General, CPWD. Dr. Chandan Ghosh, Professor and Head, Resilient Infrastructure Division, NIDM, other eminent dignitaries and speakers, all the participants. I am really delighted to be part of this conference on very important and challenging subject on infrastructure, health mapping standards, and retrofitting of built up facilities being organized by National Institute of Disaster Management, Ministry of Home Affairs. I am thankful to Professor Chandan Ghosh and his entire team of NIDM who have invited me in the inaugural session of this conference. The topic selected for this conference is very relevant and important to assess the capacities of existing infrastructure and to carry out necessary modifications, rectifications, so that these facilities may sustain the needs to the level of current requirement and future requirement. I hope the various technologies, the techniques available worldwide would be deliberated in detail and shared for health mapping and to carry out retrofitting of the structure so that the service life and capacity of the structures can be enhanced. As you know, from last couple of decades, great emphasis has been given by the government of India for upgradation and development of road in the country. We have about 6 million kilometers of road network, which is the second largest in the world. As far as density of road is concerned, we are much ahead than various European and developed countries. The Ministry of Road Transport and Highways, which is primarily responsible for development and maintenance of national highways, which is presently 1.5 lakh kilometer, and it is intended to be increased to 2 lakh kilometer in the years to come. In the last few years, various schemes for development and upgradation of national highways have been launched by the government of India. Bharatmala Pariyojana, which is one of such ambitious scheme, phase 1 of Bharatmala Pariyojana, approved in 2017, envisages upgradation of 34,800 kilometers of national highways at a cost of rupees 5.35 lakh crore. There has been phenomenal increase in the pace of construction of national highway in the country in the last several years. In the last financial year 2021, we have constructed 13,327 kilometers of national highway in the country at a pace of 36 kilometers per day. It is a great achievement, and our Honorable Minister has set a target to achieve this construction pace at a rate of 40 kilometers per day. I think shortly we are going to achieve it. Bridges, ROBs, underpasses, flyover, etc. serves a critical link of transportation network and hence needs to be maintained to remain safe and functional during their service life, to enable personal mobility and transport of goods, to support the economy, thereby improving quality of life. The upgradation of national highways that Ministry has taken up also includes necessary rehabilitation, replacement of various components of bridges and their retrofitting. As per the study conducted by the CRRI for bridge failures in the country from 1977 to 2017, the average age of failures of bridges was 34.5 years, which is very low compared to the expected design life. As such, health mapping of the bridges are very important, and timely we need to take necessary corrective measures, including their retrofitting, so that life of the structure can be enhanced, which will benefit the society and would involve huge saving to the government exchequer. The bridges and structures on national highways are designed for 100 years. Earlier bridges were designed for 50 years for 100-ton loading, whereas nowadays, considering plying of special vehicle carrying higher loads, bridges are being designed for loading of 385 tons. As such, there is tremendous scope for increasing the capacity of bridges by using various retrofitting methods. There are great need to improve the serviceability and load carrying capacity of the bridges by carrying out retrofitting, which would also reduce the damages due to seismic and other environmental factors. To assess the condition of bridges and structures on national highways, Ministry of Road Transport and Highways in 2015 engaged consultancy firm for development of bridge management system on pan-India basis. In this context, a digital platform has been developed so that inventory detail and also the condition of bridges could be ascertained and analyzed so that the necessary rectification measures could be taken up. As per the bridge management system that we have developed, we have about 1.7 lakh structures on national highways. And this was on about 1 lakh kilometer of network. After that, about 50,000 kilometer of national highways have been added. So probably now our number of structures are more than 2 lakh on national highways. Uh, Out of this 1.72 lakh structure of national highway, 40,000 are bridges falling in various categories like minor bridge, major bridge, extra long, and special state of art bridge such as cable stayed bridges, extra doors, etc. The bridge management system was helpful for identification of 700 bridges in the country requiring rehabilitation, such as replacing bearing, expansion joint, bearing cord, safety measures, grouting, crack sealing, etc. There were certain issues in the bridge management system which was developed earlier. Uh, there are various modules like deterioration modules, prioritization, optimization, risk assessment. These are also very important part of the bridge management system. So now we are trying to revamp this system, and shortly will be engaging a new consultant, and all sort of these modules would be part of this bridge management system. The assessment of bridge health index or maintenance priority index is very important for prioritization of bridges for repair and rehabilitation at network level. However, we are still in the process of evolving bridge health index for Indian scenario. There are quite number of component of bridges and more than 40 corresponding type of distresses and damages in the bridges. As such, it is a complex phenomena to evolve bridge health index. I would request Professor Chandan Ghosh and other bridge expert to contribute in the evolvement of formulation for bridge health index. The deterioration of bridges is a worldwide phenomena, and the causes for this are also well known. The bridge condition may be affected due to inadequate design, poor quality construction, overloading, congestion of the traffic, inadequate maintenance, environmental factor, unpredictable deterioration behavior, capacity augmentation, abnormal flood, earthquake, etc. The consequences faced are premature bridge deterioration, loss of traffic safety, or reduction of structural strength, necessitating imposition of load restriction and in some cases needing replacement, resulting in heavy economic as well as financial loss. Retrofitting of highway bridge is generally carried out using technical confinement of bridge piers using steel or composite jackets, installation of restrainers at abutment and expansion joint, seismic isolation through bearings, and installation of bigger foundations. Nowadays, use of fiber reinforced plastic is quite common to carry out remedial measures for distressed bridges. Normally, two type of systems commonly used are based on glass fiber reinforced plastic and carbon fiber reinforced plastic. The wrapping of these fiber reinforced plastic with epoxies and cementitious material improve the structural strength of the bridges. Some bridges structures on national highway in India have already been rehabilitated using these fiber reinforced plastic, and quite number of bridges are in need for such measures. Various aspects of health mapping and retrofitting of build-up facilities would be deliberated during this conference, and I hope this would be a great successful. It will help in capacity building. With the upgraded knowledge the participant would gather during the conference, they will be efficiently and effectively deal this matter in their respective department and organization. It is the need of the hour to map all the aged old structures and take corrective measures so as to increase the life of a structure so that the precious human life could be saved due to premature failure of the structures and also economic saving to the nation. I once again thanks for invitation for being part of this wonderful conference. Thank you very much.
Thank you, sir. Now I request Dr. K.M. Soni to deliver the inaugural address. Over to you, sir.
Good afternoon, all dignitaries, experts, and participants of the conference. Indeed, for me, it is a great pleasure to be part of this conference that is on infrastructure, health, mapping standards, and retrofitting of built-up facilities that is being organized by NIDM and CE&CR, particularly for 3 days, starting from today. Developed countries are said to be ahead from the developing countries in infrastructure development. But remember, natural disasters do not differentiate between developed and developing nations. Therefore, disasters like earthquakes, cyclones, hurricanes, floods, tsunamis, avalanches, all those disasters are common at both the places, whether it is a developed country or a developing nation like us. Therefore, this disaster management has to be made part of engineering practices. And this is being started in all the organizations, as just we have heard, and also we heard from Dr. Ghosh that CPWD is also taking up lead in this one. And slowly, gradually, all the public works department, other engineering department, they will also come forward. In fact, disaster management, when we say, then it starts from the safety or safe structures. What our aim is basically the safety of the structure. Safe structure can be built by safe design. Design is the starting point. Therefore, the safety in design is necessary. And then comes the execution of the structure. Therefore, after design, it is the execution. And then when we talk about the execution, we are to talk about the quality, as initially Mr. Ghosh also told about the quality. And then we, particularly in our country, forget when we talk about the maintenance during service life of the structure. So we don't talk about quality maintenance. So quality maintenance is also equally important during its life cycle. That what I mean to say, that during life cycle of the structure. So if we say that for a safe design and the safety of the structure, I think there are 4, 5, 6 requirements. And one is code of practices, standards, and design guidelines. And then there must be expert designers. Even if codes are available or standards are available, then there must be expert designers also who can carry out the design based on those standards and codes. Then third is expert supervisors who are responsible to implement the design, because it's not only the designs which are to be read by the supervisor, but also he is to ensure that whatever execution he is doing with responsibility. So there must be expert supervisors, and our participants, we hope that they will be expert supervisors. Then there is a need of quality construction or quality execution. Now, in construction, when we talk about the construction, that it includes the quality of materials also. As we know that sometimes most of the materials in India, what we say, the structural materials are cement and steel. So these materials, and even when retrofitting, Mr. Sanjeev was telling about that they are using fibers and all those. So quality of material becomes very important. Quality means quality construction is including quality of materials. Then comes quality maintenance. Because we know that we are designing the structure for say 100 years, and we are not doing quality maintenance, it's not going to last for that service life. So quality maintenance is also equally important. Now, there is sometimes a problem of finalizing the user's requirement. Suppose the user requirement today says that I need some slab for 5 tons per square meter loading capacity, and later it is loaded for 6 or 7 tons per square meter. This is not safe. So finalizing of users requirement timely and then intimating to the designers, it is also important. Otherwise, we are to go for retrofitting. We have no choice. So if you want to avoid overloading or overstressing of the structure, then this finalizing users requirement is also important, which is prior to the design of the structure. And in any case, these are important, and they must meet the design criteria or required criteria, whatever it is whether it is execution or design. And if that is not there, then we need retrofit. Now, retrofitting is required basically to save the property and also to save the lives of the people. And these are this is a requirement of the engineers, whatever, whether it is electrical engineers, civil engineers, any engineering field, we are taught that safety is first. So, but then remember that nature is not going to agree to us. Nature is its own master, and as such, experts have to, whatever experts are there. Suppose we are making reports, then those experts have to revise the design standards according to the nature's requirement. So the many times you might have seen that even NBC 16, Mr. Chandan was telling, that has also been revised. Even course of practice we go on revising, because we know that we are not the expert compared to the nature. So whatever nature says, we include those things, whatever, because of the nature we have observed. So we have to include those criteria also in our design standards. So design standards, codes, guidelines, even construction methods and practices, they are revised. All the engineering department who are in practice, whether it is NHAI or it is CPWD or PWD or irrigation or any other engineering department, they go on changing their construction methods and practices. And a basic aim is that such structures which are based on earlier codes are retrofitted, or practices they are required to be modified, or they are to be strengthened. So whenever we are requiring the strengthening of existing structures, and that is represented because of the design or any other reason, that is called retrofitting. Now, sometimes it becomes difficult to make in situ assessment from the naked eye. We know that earlier we sometimes usually say that that 60 years, 70 years, 100 years back, there were no so many equipment. Still, the people were having the good quality construction. Those structures, we know they were load-bearing structures or single-story structures, and safety was not to that extent at stake. But today, you know that it's not enough that we go only for the visual inspection. So what we need is that, like medical professionals, we engineers also need to assess the health of the structures. Not only through techniques and tools, but also through visual assessment. Both are included. So when we say this, then the role of indirect test, as you have seen, you have listened to Mr. Sanjeev Kumar, he was talking about indirect tests, some of the indirect tests. So indirect tests are going to play a major role in health assessment. And then IT. Now IT is coming in big way. Every time we are not there, but we can monitor the structure 24/7 basis. So IT is also going to help in making assessment even without damaging the structure. Also in communication of the results or whatever you want. And you know that one advantage with IT is that avoids human error, because earlier we were just writing and jotting down or noting down the readings, but that is avoided, and you can at any time you can download it. So that is the beauty. But you see, we are to see economics also. Now, we first is that we after we go for assessment, then the assessment of cost or retrofitting is also made, and then you are to take a decision whether retrofitting you require or you are a structure in place of the existing structure which is to demolish. And then sometimes the demolition is not possible because heritage structure is there or some emergent structure is there, then we are to go for retrofitting. So you are going to listen from Professor Chandan Ghosh regarding this health assessment and Professor Bhattacharya, and also from Mr. Manish Bharti on health checkup of the buildings. Am I audible? Hello?
Yeah.
Yeah. So then next step in retrofitting is actual implementation of retrofitting knowledge and then techniques in the field, at the site. So that is what is required is the strengthening of the structure. And the structure already has the deficiency compared to the design requirements. So let me tell you, it is more difficult than anything in civil engineering structures, because when we design or we have we are having the design, then almost it is a standard unit. Like a but civil engineering structure is not a standard unit like we have mechanical or electrical part. So it makes further difficult for the site engineers to take decision, but they have to take a decision. So there are now a large number of tools and techniques which have been devised for actual retrofitting of the structures. Now we have experts like Dr. Rai, Dr. Gopal Rai, Mr. Nitin Verma, and Mr. Ratish Jain, who are going to share their expertise with you in such for such theme or something. Friends, retrofitting is done either on design deficient structures or damaged structures. These are two requirements. Damaged structures may be either due to natural disasters or man-made disasters or poor quality construction or poor maintenance or a combination of some of them. Then standardization of practices and design of codes covering all such conditions is also very difficult. So then hence designers engineers have to take few decisions according to the site conditions. But to have confidence on the work being carried out by the engineers, performance evaluation is most critical. And therefore we go for performance evaluation, and performance evaluation may be made, we know that through numerical modeling also, but validation of numerical models is also important, and that is based on actual retrofitted structures, and that is the key of success. So we have Mr. Sandeep Sar, Mr. Chetan Raikar, who is expert in RCC and these type of structures, and Mr. Saurabh Manjrekar, who are going to give real insight of the case studies to all of you. Let me tell you, everybody, the themes and sub-themes have been carefully selected by the organizers, and retrofitting is going to be an essential part of engineering in near future. Because of old age structures, we have constructed our structures, most of the structures after independence, and therefore because of that, and two, that we are not, if we are not quality conscious, then also we may need sometimes retrofitting. So retrofitting is going to be essential part of civil engineering in near future, and it's not only retrofitting of multi-story buildings. It is going to be in the field of highways and expressways, as Mr. Sanjeev Kumar was telling. Underpasses, now a lot of underpasses are coming in urban cities, and then bridges are there, flyovers are there, tunnels are coming in railways and highways and otherwise. So even tunnels, we may sometimes we may have to go for retrofitting of some of the part or tunnels and basements. See, now because of the parking and all those things, we need basements, and we know that basements is very important structure because all the structure is existing on the basement. So all these things are going to throw challenge before us and before retrofitting engineers and designers in coming future. Thank you all. Thank you, Jay. Thanks a lot.
Yeah, thank you.
Thank you, sir. We thank all our distinguished guests for their valuable presence in today's conference. We now begin our 3-day online training program on infrastructure health mapping standards and retrofitting of built-up facilities. Today's sub-theme is health checkup of built-up facilities. If you wish to receive an e-certificate for attending this training program, kindly register yourself in NIDM's portal. Please visit training.nidm.gov.in. I am pinning this link in the chat box for your convenience. We now introduce today's keynote address and session coordinator, Professor Chandan Ghosh.
Dr. Chandan Ghosh, Professor and Head, Resilient Infrastructure Division, NIDM, Government of India. Professor Ghosh, a civil engineering graduate of Bengal Engineering College, now IIEST, Masters in Civil Engineering from Jadavpur University with double PhD from IIT Kanpur and Ibaraki University, Japan, respectively, is a teacher, motivator, and innovator for more than 30 years in various facets of entrepreneurial developments needed to cater the menace of disasters and climate-afflicted society. He works on disaster risk reduction domain, including promotion of earthquake-resistant measures, nature-based air, water, soil rejuvenations, sustainable urban system, bioengineering by vetiver grass, and has more than 150 research publications in national and international journals. He has been serving as an expert member in various committees formed by DDA, MCD, NDMA, UPSC, DST, MOUD, and MOES, to name a few. His professional acumen is effectively tapped by the non-life disaster insurance agencies, dam burst disaster planning, hydrocarbon industries, construction and retrofitting agencies, among others. Dr. Ghosh, currently member of State Disaster Management Authority, Tripura, received Leonard Prize for the Best Doctoral Thesis in 1993, CIDC Vishwakarma Awards 2013, IGS Sri H.C. Verma Golden Jubilee Award 2013, Lifetime Achievement Award 2019 by Indian Geotechnical Society, Delhi chapter. Over to you, sir.
Thank you, CE&CR team, and also I see that it is okay. I am sharing my screen. Can I share my screen? Oh, okay.
Yes, sir.
Okay. So with in the panel, I can see, of course, Professor Bishwajit Bhattacharjee is here, and Manish Bharti, who is also working quite passionately. We'll have 2 more presentations after this. And with respect to Dr. K.M. Soni and Engineer Sanjeev Kumar, Professor Bhattacharjee, I give little bit of overview that what we usually deal in disaster mitigation. So infrastructure related things, infrastructure health grading issues, I would not go into the nitty-gritty of those issues, just only give an overview in next 30 minutes. First of all, let us see that what is happening. This is a building and 7 such building blocks in sector 37D, which where about 700 plus flats are there. And then 200 occupants are there, and who have been given the notice of eviction because these buildings have been found by checking some of the components by the experts that the buildings are not fit for living. And that is why, based on the report submitted, I'm not giving all those details because it is all being taken up in a social media and many other places. But now, given that the buildings are not fit for living conditions, even though they have been constructed or given occupancy just only 5 to 6 years back. And then see that one of the tower and 2 towers where some work is going on. One of the speaker on the 3rd day is going to speak about the work that going on in such kind of, retrofitting, whatever you can say, repairing or strengthening or cover, replacing the cover, because here no additional reinforcement is being given over here. And the reason behind that, according to the report, is the water that which is being used is having a high chlorine content. Now, in our civil engineering or in this industry, which involves so many role players, need not to name, but where, if someone is doing the water test at the cost of maybe 200 rupees or 500 rupees, and if report says that water is having, what is being used here is having a high amount of chlorine, and which will be detrimental to all the concrete work or plaster work. Do you think that when 100 crore, 200 crore project of any kind, 100 crore project is going to be stalled just because 200 rupee market price report saying that water quality is not fit as per standards defined by our National Building Code or Indian Standard Code, whatever it is there? And we have to ask them not to look at those 200 families who are served a notice to shift by 1st March in another few days of time, but look at that, what kind of interpretation of such kind of results and report that would make into the minds of players who are involved to remove or shift them, compensate them, or retrofit them, or just cover them with a fresh microconcrete. It is what is to be discussed. And here is another scenario. You see, it was completely taken off, peeled off in the same building complex, and which are to be, replastered, but with no addition of reinforcement. So we do not say generally if only microconcrete is being added, then in our parlance of retrofitting, we do not say that it is rather repairing or replastering with a better say concrete or whatever is that material that which may not face similar difficulty. But when we go for checking the buildings, especially mapping, health checking, there are various stages. And these stages, like this kind of photograph it is taken, this was published in 1988 by FEMA publication, that how to do the rapid visual screening before taking up these things. So I will show some of the facets of screening or testing, taking sample to this building that which we have visited on just recently, and see that what kind of sampling is being done based on which such decisions are taken. So we have to check that what is the standards of taking sample from the existing live building before taking up such kind of decision. Of course, day after tomorrow, it will be discussed in more detail. This is just close view of the things that of those buildings that repairing work. For the repairing work, of course, more than a year it is going on. Now, the context that I would like to flag over here is that soft measures for built-up facilities to avoid large-scale damage, which I'll show a few photographs quickly. Some soft measures, not in terms of retrofitting that we understand as civil engineers in this industry. And then role of forensics in damage evaluation. We'll see that what kind of damage evaluation that we do. and then, or interpretation of the report for taking a decision professionally. Then how American Society of Civil Engineers, a professional body known to all of us, that how they make infrastructure report card every 3 to 4 years of time, and how government takes action on that based on such kind of professional report submitted by an organization that which is very much known to us. Post-earthquake event information and inspection. What are those things? I'll show a few of the things. And checking performance of building and what kind of large-scale simulation, physical test on a means 6-story building, 8-story building, which of course we do not have this facility to conduct a large-scale building, 2-story, 3-story building. We generally don't do. Rather, we do them, few of them 1-story or 2-story, but our buildings are 10-story, 20-story building on stilt, they are lying. So what kind of large-scale simulation, physical test of 6-story building, 7-story building, as of now, 8-story building, as it is, are being tested with the checking that what kind of performance live that can be checked. But unfortunately, we do not have such kind of facility, but experience being shared and information and reports that are available, they are very much enough itself to take a guidance from those reports and publications and video that are available, which I'll show a few of them. Now, in order to take it forward, health checkup for this, like this is in East Delhi, this is Akshardham temples, and you see, and this is that NH24 going toward from Delhi side to this side. Now, if you say that we are going to, because we are having a host of experts, agency for health mapping, and we have got a host of organizations dealing with retrofitting. I think taking any of this building in such area, which are highly valued, and you see the spaces from the Google Earth, it is rather health checkup for this kind of things that I am talking about the issues. Taking any measures on this in the name of retrofitting is, as they are existing, is rather inserting or infusing steroids, 32 milligram or 50 milligram or 100 milligram to the COVID patients. And we know what it is. So, whereas such kind of events are uncalled for in a highway like this, uncalled for, whereas such highways are being made, whether it is in our country, across the world, we take certain kind of measures for slope stabilization after cutting the hill slope and everything. Even then, some of this event happened. So, of course, these are uncalled for. They were not unexpected, but we took we sometimes take the risk, rarely that such kind of event happens. Once this kind of things happens, then we learn a lot of things. And then we, in order to reinstate that, of course, state or government or agency had to be ready to reinstate that, to make the road operation as squarely as possible. Whereas earthquake happens or such kind of say facilities, storage facilities are there. It is not simply earthquake. Nothing has happened over here. There are many cascading effect happens, which we are familiar with. And in our country, not such event that has happened the way that Japan, Mexico, or California that they have experienced. Cascading effect of earthquake. Of course, we are familiar with tsunami in 2004. So earthquake caused so many things, and then primarily landslide or dam failure or building collapse, and then fire explosion or anything may be cascading effect there. So our building code or any code rather, such kind of cascading effect on our facility is not possible to address in this manner. So that is why whenever any facility, whether it is a bridge or it is a culvert or a building or or a water tank, whatever we are making, we need to consider. That is why National Building Code has taken all these things in account in 2016 version, that what are the cascading effect, how parking facility has to be made, and then in case of earthquake or in case of flood, what are the secondary, tertiary things are going to happen. So I'll give some of those examples. Okay. Now, let us see how many hours. There are many bridges are failing, but as way back in 1964, due to Niigata earthquake, Shinano River, this bridge, Shinano River, Niigata city, 1964. The thing is, how often we take up a failed such cases due to earthquake or any other event, we go below the ground. See that in 1964, what really caused this bridge to fail is known by the earthquake, but a new event that have been given a scientific, anointed with a scientific, or in our technically, even though things are happening much before, even in 1934 earthquake also in Bihar, Champaran area, a lot of such liquefaction has occurred. But liquefaction, we have coined a new thing about the foundation failure, especially near the delta or something. But how many such investigations that we have taken into as a professional to go below the ground and find out that why this deck over here, why it has come down like this, and then finding out the details that this pier bend this way, this pier bend this way, because this is a middle span, and middle span is not having any hinge. Whichever is having the hinge and roller support, these are the basics, that this is the reason behind that. So in 1964 Niigata earthquake has given the scientists to go below the ground. And having such kind of failure that happening across the globe in the earthquake prone area, knowing that such kind of things are happening, how many of us as on date have taken such kind of proactive measures by creating such kind of prop or support or dampers? I think very few are not yet attempted or not yet thought of. So we have to see more detail. Like this one, 2011, 18 September, Sikkim, Nepal border earthquake happened. And this bridge is more than 70 kilometers away. This bridge were functioning well due to earthquake, nothing overly seen on this bridge. But after 3 months, exactly after 3 months, earthquake happened on 18 September, 2011. So this bridge was crossed by some of the heavy equipments required for making hydro power stations on the northern part of Sikkim. So it didn't attract any attention that due to the earthquake shaking, existing structure also experienced some kind of cracks or some kind of deterioration, its property. So post-earthquake investigation is not that after failure we go, but health mapping that have to be done after earthquake on any such kind of structure, whether a bridge or buildings and other thing, what kind of cracks or progressive failure has occurred. Had we had checked this thing, in fact, in 2011, we didn't have any such program to check the facilities that which are still existing but not yet failed, resulting that when this trawler carried over this, it has collapsed and creating such kind of mess. It is not only that health structure, but at the same time, we have not yet progressed enough to stop a train or to stop a nuclear facility due to earthquake or any such natural event. Like in this case, a Shinkansen or bullet train was stopped on 23rd October 2004 by putting a automatic brake within 5 to 7 seconds after the occurrence of the earthquake, 2004, almost 16, 17 years before, mid-Niigata earthquake. So auto brake has been applied on this system, on this car, on this train to save this thing. It has derailed, but it has not killed. So in that case, what are the background system that we have to put in place? It is still lying in the dark box that our scientists or our earthquake or specialists, seismologists, technology, civil engineer, all together, we are still looking at the science aspect of the predicting more, or rather putting a system to catch the earthquake young, or to catch the earthquake within few minutes. Rather, by few minutes it has gone 400 kilometers. Generally, an earthquake of 7 and above, their devastating area are limited to theoretically say 300. Or Mexico earthquake in 1985, or Sikkim, this Bhuj earthquake, it has taken a different kind of perspective on this ideal assumption of 200 to 300 kilometers of devastating area. So what are this kind of system to be in place? We have not yet explored into. Now, there are certain things that not about the earthquake, but making flood walls, we can save many such facilities in our country, like increasing the navigable capacity of the river or stream or canal or whatever it is, putting such kind of soft measures quickly, putting sand back, but these are all polymer material, filling up with sand quickly to increase the capacity of this thing so that such facilities are saved. This also comes under seismic, not rather health mapping of the facility, built-up facility. Or health mapping also should include that maintaining a functionality of this 8-story building, hospital building or essential building, by simply making some effort in the retaining wall that which can stop water entering into this, or even stopping the water on the road by such kind of polythenes or such kind of polymeric materials which are being evolved from the petroleum industry, quickly placing them, stopping water going further this way, or even stopping water into our compound. Like most of the multi-story buildings are having even 2 or 3 tier of underground. We do not have any arrangement in our multi-story buildings which are soft. Not only that soft story is there, which are dangerous. I'll show with a video on that. That experiment has been done. Rather, such kind of measures, if we include into our health mapping issues of our facility, probably will be serving a lot of positivity into the community as a professional or the community involvement. Or even making such kind of structures, such kind of things quickly. If we make it, we can save these facilities. Though in this series that we are looking into the earthquake related things, but there are many such kind of soft measures that help us checking the damages into our facilities. Now, coming into the second part is that mapping, that American Civil Engineer report card that they have given, and that they have overall in 2021, they have given C- grade. C- grade we understand in class or any student that we are giving C- is out of 10, maybe 6 or 6.5. So that is the grading, overall grading they have given to their infrastructure. In the year 2021, it is a report came up available freely, and the federal infrastructure bill has passed in November, and the bill addresses 16 of the 17 categories outlined in ASC's 2021 infrastructure report card, and addresses more than 40 of the solutions laid out in the ASC's report. And what the report has says that, which has discussed all these things about the capacity, condition, funding, and $1.2 trillion has been given now in November 2021 for next 5 years in all the states. And so operation and maintenance, how it is in the report, AC report has mentioned all these things, how it is to be done, and resilience, and then innovations and everything it has given. So otherwise, the report also contains such kind of things. By 2039, America's overdue infrastructure bill will be coming rupees $63 a week. Probably we have to look into that, how to make health mapping of our buildings, infrastructures and everything, whether it is bridges, tunnels, roads or everything. We have to look at this aspect also, how much extra bill is going to be given per capita if it is not taken in time. So in this case, they have made about 19 category of infrastructure. So in this 19 category of infrastructure, you can see aviation, bridges, broadband, even broadband comes into there. National park also comes, drinking water and other things. We are spreading all these things in our country as of now, but we have to look at that, how to maintain their health and how to check their functionality while they are in use. So these are the grading that they have given to all those 19. And you see that overall grading is C-, and then aviation B+, it has gone up a little bit, bridges gone down, something like that. So these are the things that a report is available, one can see. And as far as going to the market intelligence and other things, we are so much overpowered, or we are so much in favor of going for big data, blockchain, connectivity, IoT and all these things. So IoT is going to make many of our health mapping system and drone and other things more rational. And but of course, it requires lots of experience, knowledge base that we are having with our engineers who work in the field to verify. Otherwise, simply going by this kind of data and other things are not going to help. So such kind of things are going, taking a lot of attention. Digital construction and other things are coming up, but we are able to check now many of the things automatically, and many of the panic button and other things, carbon dioxide things are also coming there. Such kind of devices are being put up in many facilities, and they are collated into building information system. So before building crackdown or anything, which is our main purpose, we can have an association of such kind of smart sensors and other things, of course, and so that we get certain kind of information daily, and even live simulation can be made. So anyway, some of these things have come up in our country as well, that where panic buttons and other things are being used, or even in Chennai also it is there. So which are now taking up the market. So which I would like to say that health mapping with our own experience that we are having so far, it can be augmented by using many of these facilities and putting them and testifying their association into our investigation during construction, even post-construction or post-damage construction also. Like we expect something like this. And now I would like to say that we expect something like this, that before earthquake comes to my place, we want that this red colored S wave, how much time that it is giving us, it is like 27 seconds. After 27 seconds, it will come to the spot that where I'm having with my mobile phone and GPS, having GPS. So such kind of things need a background, such kind of things. We have not yet explored into this, although IIT Roorkee has started these things, but it is still in the pilot mode. And let the people should know that before earthquake arrive at a spot 3, that it has got 28 seconds to reach to the spot 3, and with the intensity of 6, intensity shaking, and the magnitude of earthquake that happened is here. But still, in our country, we get some kind of small information in an A4 size paper with a 6 million scale. We do not get any picture. Rather, we get after maybe a few minutes or something, that an earthquake has occurred. Even Delhi, like here, even 2.1 magnitude earthquake is also a news. Okay. So anyway, I would like to end over here. Like these are the information coming to our information every day, every moment with all these things, which we are not connected much about the information being shared and being taught by a voluntary agency. There is no, it is all public funding. There is no government funding is there. But these are the information, professional agencies, scientists, all together, more than 70 organizations, they work together, keep these things on the globe based on their hobby, that these are the information that being shared for the common public and community. So, so anyway, like this one, we are making such kind of buildings, and we still say that they are safe as per code, but code will never be able to make such kind of building safe against earthquake, even though it has given with code language that stiffness variation, stiffness should not change. That doesn't make, we should not encourage such kind of building. And then the effect of unreinforced masonry infill into the design, how this is to be taken. Otherwise, we'll see such kind of failure is going to take place. And but as far as retrofitting measures and other things, such kind of cross bracing is elegant enough. And but otherwise, making on the building that such kind of at least a wall or boundary wall like this can give some kind of surety about the seismic safety of such kind of multi-story building lying on stilt. So thank you. I would like to say that the quality of taking sample from the building site that which I have shown in the beginning, see that whether they have been able to take the core or not, whether they have been able to justify taking some kind of sample and peeling off so much area, and what kind of tests and evaluations are going to be done in the laboratory. I think, you know, and also cutting and leaving this kind of, taking the sample and leaving such kind of scar onto the bottommost column is not the technical or scientific way of justifying our profession in assessing health of the building. Thank you very much.
Thank you, sir, for the wonderful presentation. Now, we would like to introduce Dr. Bishwajit Bhattacharjee. After the introduction, we request Professor Ghosh to share some memories about Dr. Bhattacharya before we begin today's lecture. Dr. Bishwajit Bhattacharjee, Emeritus Professor, Department of Civil Engineering, Indian Institute of Technology, Delhi. He has a BTech Honours degree from IIT Kharagpur, MTech and PhD degree from IIT Delhi. He has worked for Gammon India for 2 years after his BTech. His research interest pertains to the domain of cement and concrete technology, building science, sustainable construction, and health monitoring of structures. His publications in these areas are well cited. He is also a recipient of the Indian Concrete Institute's Lifetime Achievement Award. 5 NPTEL courses, including one on concrete technology by Professor Bhattacharjee, is available in YouTube and NPTEL platform. Over to you, sir.
Okay, so it is a really pleasure, sir, having you. Due to COVID, we could not meet, although we had the boundary wall only in between your residence and my residence in the south part of Delhi. But we know that you are a very good football player. But of course, these days, social media is not there. Maybe I would say that beyond your professional domain, that where you have concretized your knowledge, know-how, wisdom, services with your lovable spirit among all of us, and which is a par excellence. And having you here in this online mode is sheer encouragement for all of us.
Sir, you are not audible. Still not audible, sir. No, we can't hear you. It's not audible, sir. Please check your mic settings.
Is it audible now?
Yes, sir.
Yeah, I think so. Yeah, there's a little bit of problem. Anyway, thank you very much. Thank you, Dr. Ghosh. In fact, I have a friend, I believe he is your relative. So one day he said that, hey, we are young friends, Joytosh. So I said, do you know that Dr. Ghosh has got double PhD? I said, no, I don't know. He says, I have heard of people even doing a double MA, but somebody doing double PhD is something extraordinary. So you are an extraordinary person. Thank you very much. Thank you for all the nice words. And thanks to Pravir Bhattacharjee, my dear good friend, and his CE&CR and Revered Media. So thank you very much for calling me here. And I'll try to, give some sort of an overview of the whole thing as much as possible. Some ideas related, but more towards deterioration related health, handling or health checkup of structures. So I can share my screen. Is the screen now visible?
Yes, sir.
Okay, so I can go ahead, right? So that's what I'm going to talk about, health checkup of built up concrete structures. Now, a little bit of fundamental, of course, health. So it actually boils down from human bodies, and it could be routine or post damage, routine or post distress and damage or oblique damage. Can have a legal risk or perception. Can, you might need this health checkup after due to legal, like human being needs for insurance or for some risk perception that you are likely to have, one should not have, likely to have some sort of health problem. Then obviously when there's a distress, then you need repair, rehabilitation, retrofit, strengthening and all that. So certain definitions, quite often I find whenever I'm talking that there are some sort of confusion related to some definitions or terminologies. I thought I'll just start with that. Now, damage is due to overloading. And damage or distress can occur due to deterioration also. Now, deterioration is essentially due to degradation of material, leading to serviceability limit failure. Damages can lead to collapse as well. But most often deterioration do not lead to collapse, although the damage overloading may lead to collapse. Several of the pictures shown by Dr. Ghosh earlier, some of them are failure. And life, I'll define them slightly more here. I'll go to one of those slides. Repair relates to restoring the functional performance to an acceptable level. Patch repair, quite often. Rehabilitation is related to complete structure, and retrofit may be to a currently acceptable, up to a currently acceptable standard, even though nothing is functionally performing. So earthquake retrofit, I mean, it's fine, it's working, no problem, but your risk has changed, risk perception has changed, not really risk has changed, risk perception has changed, the code has changed. So you retrofit it to the recent, to the current requirement. Energy retrofit. There are several other retrofit tools. They are not same as possibly rehabilitation. Rehabilitation is essentially related to some distress. Confinement of members, quite often my earthquake engineering friends, when they do repair, they will ask the beam column junctions, confinement with fiber wraps, and then strengthening. So strengthening is jacketing and things like that. So let me come to life a little bit more. Now, quite often, I have seen sometimes somebody saying, oh, concrete has got, somebody asking, concrete has got 100 years of life. I mean, how can concrete have, you can define life of concrete for 100 years because it's an inanimate object and doesn't have a defined sharp boundary between life and death. So what we talk generally of intended design life, like a monument might have an intended design life for 1,000 years. Intended design life. Physical life can be very, very long. Many of those Roman structures, the Dhamek Stupa in Sarnath, they are there, they're prior to BC, BC, before Christ. And they're still there. Economic life, after which you think maintenance is too costly and therefore you will not continue with that life. Functional, like cinema halls turning into shopping malls. So functional, the load would have also changed. Some of the bridges, functional aspect might change. And service life is related to serviceability limit. I'm talking of concrete structures. So therefore serviceability limit we design with limit state and therefore serviceability limit is there. Service life is related to serviceability limit and residual life actually is expected, I would say, because you cannot really predict the residual life. You can always calculate the expected residual life. Thus depends upon context. So this is the important aspect. But then service life is something like this. You know that there will be maintenance. There will be maintenance issues. There will be maintenance issues, because deterioration can occur. And normally accepted level is here and your intended service life is here. So a particular element, this is related to element, not to the whole structure. For example, a bearing of a bridge, bearing of the bridge girder or something like that. Now this will have a service life. Even the girder may have a service life, after which if you do the repair or even replacing may not be very easy, but buildings, of course, you do repair like cover concrete changes and things like that. So normally accepted level, you might do the repair and then again it will deteriorate if you keep the same thing. But if you do a better repair, you might even take it to the intended design life. Generally, one would like to have a maintenance-free intended design life because disruption cost is pretty high. So durability of structure is qualified to that actually. TSL is T ideal is perfect durability. That means maintenance life is, there's a same as the intended design life. So one can look into this in terms of life cycle cost. And life cycle cost is very important because that will justify your health checkup or anything of that kind. Now, where CI, this term is initial cost. This is a term for extra quality control. For example, Dr. Ghosh was also just talking about, and there are several cases I have come across in building, which some of them, Mr. Manish Bharti would have also come across. He would be coming across. He would have also come across many of them, where you have rebar corrosion problem in buildings in the central India, eastern India, northern India, not in the coastal area, not necessarily in the coastal area. This is not because of anything else, because they have used land quarried sand unwashed and water from the groundwater, leading to a lot of chloride ingress. I mean, chloride, internal chloride, not ingress, internal chloride. Now, a little bit of test, maintaining better quality control would have saved this. So, the life cycle cost deals with this initial cost, plus this is the inspection cost, maintenance cost, repair cost, and this is probability of failure in case there is a failure, and this is the cost of failure. If there are, there's a probability of failure going basically going from this is going from 1 to n. Tn is a time, and if you think m such serviceability failure can occur, then this is a probabilistic, because you don't know really quite often, and there's time value of money, there's interest rate. Because whatever would happen in future, you bring it to the current state. So life cycle cost can be written, a model like this for the life cycle cost can be written in this manner. Now, you spend a little bit more here, possibly you'll save on all this. And this you'll definitely reduce on PFLS, probability of failure. And, so this is the serviceability failure, basically, so cost, you can see. Now, inspection, if you increase, this cost and this cost would reduce. So cost of inspection is important, and that's where the health checkup comes into picture. Obviously, improved specifications, not only quality, but specification also lead to less maintenance cost. So health checkup is related to this. As I said, it could be, it can be routine. I don't know whether I have mentioned this or not earlier, that it can be routine. It can be, I'm not sure whether I have just mentioned this, or I'll go routine or post distress or damage. So routine is actually more related to health checkup. After distress also you do the health checkup, because if you have got a disease, you'll do your health checkup. But routine is the one I'm talking of. More importantly, one should be doing, and it would save a lot of cost. So save a lot of cost actually, in the long run in terms of life cycle cost. Now, major factors which affect the condition of the structure, why you need actually maintenance and all that, or inspection. Obviously, quality is important, environmental condition is important, but loading conditions also play a role. Because fatigue loading, where you have reversal of stresses, crack can come at much lower level. Although reinforced concrete, concrete do not have a fixed endurance limit, as we call it, but it can crack at much lower level than the static monotonic load failure. So exposure environment should involve both environmental condition and loading in the context of health checkup. Simply, you can classify this as health checkup as aggressive and non-aggressive, and loading can be classified as static or fatigue. So then this is from CIB. It's a European, possibly French acronym for is a international better committee for concrete. So what they classify is, they say that a very severe environment will be aggressive environment with cyclic loading, and severe will be aggressive environment with static loading, or non-aggressive environment with cyclic loading, and normal is non-aggressive environment with static loading. And they provide a guideline for 3 types of structures which are important, because everywhere you are not going to do regular inspection, right? So class 1 is vital importance to the community, or failure can be catastrophic, like something like even some bridges can be, or because it can cut off certain portion, and therefore the supply to particular area might be stopped. And nuclear reactor structures, these are definitely there, dams, etc. They're obviously class 1 type structures. Class 2, considerable importance to community, or failure may cost lives, right? And class 3, for example, assembly halls and things like that. All right, but then there'll be no, when you are looking at things like general scenario of the structure, its resilience against various kind of sudden loads like earthquake or wind, that is a general one. But then assembly, etc., the failure can be catastrophic. But deterioration normally never comes suddenly. It gives you a lot of signal. I was a bit surprised reading the newspaper other day why the collapse of a particular floor and things like that when there are no actually natural disaster. So it must have been a lot of things must have gone wrong there. Anyway, I have not looked into those kind of things, but deterioration, if it is only because of corrosion or something like that, failure doesn't occur suddenly. Class 3 is unimportant and no fatal consequences to lives. So that's how they classify and give a suggestion for inspection of structures. If your environment is very severe, very severe, that is, you have got fatigue loading plus aggressive environment, then every 2 years you must do extended inspection. Extended means something more than a routine inspection. And every 2 years you should do routine, which means that this year I do routine, next year I extended, next year again routine. So for example, a thermal power plant just by the side of, let's say Western coast, Gujarat's coast, which I saw one, BHL was supplying machines there, or maybe they were constructing it. Now that's really in an aggressive environment. What if the turbine foundation, not very far off from the sea coast, if it is there, if it is within 5 kilometers, the aerosol can come. It's a really aggressive environment, and if the repeated loading, one must check this very regularly. If it is class 2 structure, this goes to 6 and this 6. That means every 3 years you will do. And then this is class 3, not important structures, 10 years, but this is all in very severe environment. In normal environment, you're going to do anything for class 3 structures, others you can do like this. So that is the guideline they have given, and I think this is quite fine. This is quite all right. And interestingly, at least one organization where I have done a job for them, they were routinely inspecting their properties every 5 years. Reserve Bank of India. First time I did, and after that I said I don't want to do it because it's become repetitive for me, and I'm not enjoying it anymore. And the best building amongst all the buildings that I actually investigated at that point of time, somewhere in 90s, best building was the one protected by Yaksha and Nakshi. That is the Reserve Bank main building. Then apparently the construction has been very good. Nowhere I found the cover less than 25 mm. And it was, of course, mild steel, 1940s, late 40s and early 50s construction. So it seems to be interesting that Yaksha and Yakshi actually, who are there in front of the building, if you have visited it, the sculpture by Ramkinkar Bej, famous sculptor. So they are protecting the building as protected, and sure the building is also well protected, very well protected. But other buildings had problems. Some they have in fact demolished. Normally, if you don't do the repair in time, cost increases. For example, it can be parabolic, like delta CMT. I'm saying delta CMT, rate of change of per year increase in the cost of maintenance, right? So delta CMT per year is this. So if you, in 2 years, it will simply, first year it will be CMT after 1 year, if you have delayed the repair. So this is at the point where you should have done the repair. Next year it will be twice CMT, 4 times CFT, and so on in a GP series. Parabolic curve you can assume. I'm just saying parabolic, but it could be even exponential. So maintenance cost growth is like this. So therefore, inspection saves. So in a nonlinear fashion, it improves, and timely survey and inspection can result in saving. Supposing you do inspection on an average T years, then repair average delay in repair will be T by 2, because you can do tomorrow, it was repaired today, you would have inspected it, just before inspection, you might have done a repair, right? Or you might do delayed to 2T. So if you do inspection, just after inspection, next day you have done the repair. So it is immediate, or it has so happened that when you have inspected, it is already nearly T time has passed. So average repair time will be T by 2. Total cost of survey and cost of repair one can calculate out, and this can be minimized to obtain the uh, optimal time of inspection. So one was the guideline that I talked about. Other is you can even, if you have the data, you can increase your inspection frequency, inspection cost will increase, but the cost of repair will increase. But you remember somewhere the disruption cost is there. You stop a bridge, well, it can cost hell of a lot. For example, if I mean, since I come from Northeast, earlier there was a time there was only one bridge, Saraigat, near Guwahati. So if that bridge you stop for one day, this will have all kind of problems for Northeastern people. They will not have supplies. But now, of course, there are many parallel bridges. There's another one by the side of it, road bridge. There are one in Koliabar, Tejpur. There is another in Bogeyville. So there are several bridges. Now it has come. But you just imagine a building, if it is housing a mall and it is closed down for 7 days, it could be terrible. That's disruption cost. So this also has to be taken into account. So inspection or health checkup might be a good idea to save this cost. So this, that's the model that I was talking about. I did the rough calculation, I mean rough modeling, but not for you really, not necessarily, because this is for my class students. Now, one special case is continuous health monitoring when T equals to 0. Please tell me when I have to stop, because if I am not, I do not know whether how much I'll be encroaching upon Mr. Manish's time. So let me know if I have to stop, then I'll go a little bit fast. Now, quite often in India, of course, condition survey is carried out buildings, particularly after observing a distress. That's not the best way to do. Saving, it doesn't save cost. If you have monitored in time, I mean, if you have done a health checkup in time, it would have saved a lot of cost. Health monitoring is continuous health monitoring, obviously. T equals to 0. But cost has to justify this. I'll come to this. The cost has to justify this, right? And today you have got all kind of, techniques. I'll discuss some of them very quickly because it's just introduction, and some of the things, ideas have started coming, research ideas, and some sensors are being embedded. Sensors are also appearing. So I've just included them with a little bit of principles. And obviously, the major cause of deterioration in this country is river corrosion, but for wrong reasons, actually, for construction, inappropriate construction practice, I'll say, right? Because not using right kind of material, not testing material is a very big thing. And I have one of those couple of months back, I think I did it for an ICI lecture, similar sort of thing, and I showed how many data in 1990 to 2004, or even recent time, all the tests that I have done as consultancy job, many of them I've compiled, and majority of them are rebar corrosion due to internal chloride, because people have hardly tested water, or even sometimes the fine aggregate, quarried them from land. So anyway, coming back to this, T0 should be justified by, so very important structure, class 1 structure in aggressive environment. You can put in T equals to 0. That means you embed sensors, and bring in something. So which I'll discuss a little bit. Now, in this context, this is a kind of exposure zones which I proposed in 1 or 2 conferences, of course, and some of my lectures for India. This is very much India specific, because it should be based on, just next slide, and then I'll go back again. It should be based on our climatic conditions, right? And we have a dry climate here. We have a relatively less humid climate, although it's very cold. And these places, this is warm, humid climate, and this is the seashore, the black line. So most severe is this zone, 10 kilometers, and a lot of rainfall zones, warm, humid climate, that's also a little bit problematic. So based on this, one can classify India into 2 kind of zones: marine zone, for service life modeling, which we have been doing, calculating the service life of elements, marine zone and non-marine zone. Now, marine zone is, I think it is 7,000 kilometers, if I'm not wrong, something of that order. So we can have submerged, plus zone and offshore. So submerged is within water. Now it will be chloride ingress in saturated concrete. And one can model them, but I'm not interested. So this is a boundary condition for the differential equations that one uses. Splash zone is the most dangerous. Chloride diffusion, solution diffusion through water comes in, so that leaves unsaturated concrete and the boundary, etc., etc. But offshore, 5 to 10 kilometers, that's also dangerous. And the others, no, hot dry desert, they're the moisture ingress during the monsoon season. And that can lead to, if you have internal chloride, it will start corrosion from the very first year when more moisture has gone in to the exposed concrete. Wind-driven rain is the one that brings in the moisture. Warm humid climate, just for a longer period of monsoon. So the moisture remains there for much longer period. And therefore, period during which actually corrosion or deterioration will occur, because if there is no moisture, no deterioration will occur. And composite monsoon is a central Indian, Delhi and things like that. And there again, 2 months, 3 months monsoon. So it's relevant to this. So very high precipitation zone like Kudai Canal, etc., etc. So one can classify this, and this would definitely, this zone, if there is a structure like bridge, this zone, this will be class 1 type. And you've got to do inspection, and possibly all the time you can even embed sensors there. So this is the possible zones that I talked about right now. MZ1, MZ2, MZ3, non-marine zone and non-marine zone. One is the red one is non-marine zone dry, and non-marine zone wet, I'm talking of, and non-marine zone moderate, and very high precipitation zone, there are some, and rest of is marine zone, the line. So periodic inspection is very much necessary, which would need systematic visual survey and document survey. Selection of test and actual test and update is not after. I'm saying, I'm not discussing today after, post distress scenario. I'm only talking health checkups generally. Selection of test and actual test, and decision on action, what you are going to do. If you are doing continuous monitoring, today you can do automatic image capture, and artificial intelligence comes in there. So neural network, etc., being used. People are trying them, but they're at the moment research stage. Sensor embedment. Technology have come. When I was searching a little bit, in 2009 or 10, people have published papers on embedment. And what I understand is perhaps commercially these are available not in India but abroad. I'm not sure in India it is available or not. Because other day we were in an international conference where I was presenting Keynote, and before me was Professor Bashir from Leeds. He was also presenting, and they said that they have embedded sensor, corrosion monitoring sensors somewhere in Hong Kong, near Hong Kong or Singapore, one of those city states. I mean, Hong Kong earlier city state. So the literatures are available. So commercially also it must be available. Decision on action. So once you see, again, artificial intelligence can come in. Drones, these are also there. I suppose one of the projects, CVRI, I mean, there are organizations like CSIR Labs, some projects are there with the drones and things like that they've been doing. Coming to visual survey, we did some work. And one of my students is a professor in Munjal University, Dr. Kamal Jain. His PhD project involved this. So what we did was we did, collect questionnaire survey from all across the globe, from 50 people. And then we said that, okay, if this is the kind of deterioration or distress, I'm giving example of only corrosion. For example, one example of corrosion that you have seen, rust staining has occurred. Rust staining has occurred. And severity is minor means not over very large, it's only few places. Moderate means over, just quite a bit, and extreme is more. Local means over a small space, minor cracks or minor last training, lot of last training, but over a small place, area of the element. And global means over the whole area. So we did codify, and this is this code according to this course, and this is the description. So the inspector has to look at this and just record this code and nothing more. For example, if this is the case, this is a live case. I wouldn't say where it is because that is where I stayed majority of my life. And even there, there's the chloride, internal chloride. No, I think it's bank building, maybe bank building, not very far from IT campus. So this was global, depression of size more than 20 millimeter depth. So cover has all come out, 100 millimeter. It's all visible more than, So this classifies it to be a global. It's a global all over the place. So corrosion, spalling, external, So this code is there. So because is that tool which he developed in the course of his PhD. It's an Excel-based code. We couldn't commercialize it because you're a bad salesman. I'm not sure did Manish try it or he maybe because Kamal worked with Manish for some time. But perhaps commercializing it would have been a good idea, but we are a bad salesperson. I particularly am a teacher, so you see the condition indices we developed based on the survey from international, national, and international people, and using fuzzy mathematics, we could come at some condition indices. So for each element, what is the condition, and this can be combined again to get the condition of the whole building. And if you see every 5 yearly, that would be or 3, according to your inspection, it would give you a good idea how it is changing. So this is related to building. Now I'll talk about a few test things. This is where people know it very well, half cell potential test. But more importantly, this can be embedded. Another point which I want to mention here is that although I couldn't put that slides on, because we use this to detect chloride-induced corrosion initiation. So if you can embed that effectively in the concrete itself and monitor it from time to time, but this would continuous monitoring may be also possible because using today network, all sorts of network, you can connect them to the network and get signals from this from time to time, but it has to be moist. This concrete has to be moist. So knowing, you have to, judiciously apply this embedment, and it is available. Perhaps some of the research paper I've seen where they have embedded upsell potentials, probes, and you can monitor the potential. And when the potential goes beyond a particular value, corrosion would have initiated. It is, depassivation would have occurred, as you call. So this is possible, and we have seen that this exists a good signal with respect to depassivation or initiation of corrosion, electrochemical corrosion. Dr. Professor Bulu Pradhan, IIT Guwahati, who is also my student, this was at that his PhD we did all this. This is a small case. We did a half cell potential mapping, but discrete one in one of the balconies in IIT long back. But there are instruments which can do multiple half cell potential, multiple probe, and they can give you this idea where the risk of corrosion is very high. So this is external instrument, but you can embed them. That's what I say. So this is a simple one. Instruments are available today. Then impulse radar to locate rivers. This becomes very important. We do, of course, ferroscan and all that, but impulse radar gives you a good indication of river locators. Like something like this, the impulse radar will give you, but signal has to be read. It's not easy. The expert, one has to be expert in the interpretation of this results. So this is ball locator, and this is totally non-destructive. It will give you much more accurately than your magnetic type of ones, which is based on, they have good softwares, but basically half transformer. I didn't cover that, but I thought this is another, but I was asking for, this LPR measurements. This is of course the schematic again of LPR measurement we did in the lab long before instruments were developed, but today commercial instruments are available. I'm not talking about this. This was also done by one of my students during his PhD in 95, Professor Shamsad Ahmad, King Fahd University now. And guard ring, this was not available. Now commercial instruments are available with guard ring. So this is again, this for example, Repicor. You can go and measure, right? AEC, Eventech, Parampreet Singh, he sells and he does testing also. So he's the one who supplied us this, and you can, it has got guarding as well, and it gives you basically you can find out the corrosion rate in structures non-destructively. Linear polarization technique, same technique I was mentioning. Now this is the embedded LPR sensors. So currently these are available. What they do is they put this sensor in a motor. Like you have got, cathodic protection, sacrificial anode capsules today. I just wanted to include this because embedded LPR sensors are possible today. And I'm not sure whether in India anybody is marketing them. So in very important structure, one can put in them, particularly in the, I said the splash zone areas and areas near seashore. Obviously, your concrete has to be free from internal chloride. One of our very recent study showed that even near sea coast, there are a lot of internal chloride, not really external. 5 kilometers within, there's 800 meters from the seashore, because they would have used poor quality water, or but I don't know what happened. You can find out by yourself. So this is embedding it in mortar, and this system cell will be embedded in the concrete itself, and you can monitor. Magnetic mass probe is another thing I want to talk about. This is totally non-destructive, and can tell you whether how much quantity of rust is there. Somebody asked me before I retired some 5-6 years back. He said he came and somebody was selling it in India. And I asked what is the cost. So he said that that point of time, maybe 7-8 years back, around 35 lakhs. Anyway, I was not interested because I was not continue for a very long time. So it should be younger friends of mine who should be buying if they are to buy. So this can tell you how much is a rusting that has occurred. But these are okay. Some more sensors I just want to talk about. These are also one can embed them. Bregg's grating fiber optic sensors. I had a chance to work with fiber optic sensing in '99 in EPFL Switzerland. But unfortunately, then Bragg sensors were not there. What we were using was Michelson's interferometry. They are very slow, but this is far better. I'm not going to the principle of this today unless somebody asks this question. But basically, they measure length change, right? So the gratings are there, and then as the length change occurs, the transmitted signal will change. Suppose transmitted and reflected signal separate. The grating spacing will increase. So if there is a strain in this place, so they actually measure the deformation. And one of the sensors called Brillouin sensors, which have been again attempted to use in river corrosion expansion. So they are for basically length change measurements, and there are commercial equipments available on this. The other where we did work here in Delhi on my colleague who's a master in that, Professor Suresh Bhalla, so jointly worked on this for corrosion purpose. So when it was corrosion, he of course was nice enough to call me and take my expertise. And Dr. Dhawan is one of them who did his PhD as well, used some of them. And another, Dr. Vishalakshi, she also used some of them. So we use this for corrosion measuring also, but they can measure damage. So piezo sensor, lead zirconate titaniate, the simple principle, if you put stress, then it generates electricity. And if you, it's other way around, if you strain it, then voltage can be generated. So that's basically piezoelectric sensing. And so you apply stress, it generates electricity. And if I think I'm going, it's almost 5 o'clock, so I will not be leaving much time for Manish, so I'll have to quickly finish it. And this can be utilized. We tried to use them in the laboratory for corrosion monitoring, because corrosion could cause changes in electromechanical impedance, and that one can monitor. I will not go into theories, so these are equations, I'll just leave it out. but this can be used, piezoelectric patches can be used, and one can find out if there is some sort of damage. So corrosion damage also we try to find out with this. And this, I'm not sure commercial equipment is available on this or not, but patches are there, and commercially available, pretty cheap, not very fast. It is used for several things. Okay, right. So dynamic periodic electric field would induce periodic strain, etc., etc. The back-induced periodic stress is a function of stiffness and damping properties of the substrate structure. So induced charge density, displacement, etc. we can find out. From this, one can find out. So I think this is where I'd like to end. If there is some discussion or something, I'll be very happy to discuss. There are several other modern techniques are coming based on this, and embedment is possible for deterioration related health checkup. So continuous monitoring is possible, and there are a lot more things coming, like I said, artificial intelligence and all that. Thank you very much. Thank you for hearing.
Thank you, sir, for your insightful presentation. National Institute of Disaster Management and Civil Engineering and Construction Review presents Certificate of Appreciation to Dr. Bishwajit Bhattacharjee for the expert lecture on health checkup of built-up concrete structures during the 3 days online training program on infrastructure health mapping standards and retrofitting of built-up facilities from 23rd to 25th February 2022. Now, we would like to introduce Mr. Manish Bharti. After the introduction, we request Professor Ghosh to share some memories about Mr. Bharti before he begins today's lecture. Mr. Manish Bharti, Chief Executive Officer, Cortex Construction Solutions Private Limited. He is a Bachelor's of Engineering, Civil Engineering 2006 from Delhi College of Engineering. Mr. Manish Bharti is a structural and diagnosis consultant since 2006 and a member of ACI, American Concrete Institutes. He is currently CEO of Cortex Construction Solutions Private Limited, which is leading private company in this domain and has been known for its innovative structural audit approach through the various diagnosis systems. His primary research interest lies in understanding the behavior of structure, material characterization, development of diagnosis systems for all kinds of old structures, and designing suitable repair and rehabilitation techniques, instrumentation and load rating for the operation load. He has been involved in a wide range of consultancy jobs for rehabilitation projects, more than 1,000 structures from industrial buildings, bridges to heritage buildings. Over to you, sir.
Good evening. Hello.
Yes, sir, we can hear you.
Good evening, sir. I have worked under B. Bhattacharjee, sir. He has been my teacher, and I learned first time to analyze the data related to the diagnosis outcome, whatever generated by the different equipments or sensor or some NIDM equipments. So interpretation is the one of the major part of the analyze the any kind of behavior or material characterization of the building, because the data totally depends upon the who is going to extract the sample at the site, and how sample is extracted, and how sample was preserved during the testing or before the testing, and then how we use to record the data in defined format. And last, we use the some interpretation table by using the different codal system. So every time with the time and passing the years, generally code are changed, particularly in the civil engineering, because code is updated time to time on the basis of the experience, and with the changing of the design system, codal provision, or the loading pattern. And there are a lot of factors that is those are going to define our interpretation system. So basically, if you go with the analysis system, just I want to share my screen. So whenever I generally approach or Cortex is approached by any client, they generally ask about the current status or current health of the building, and they want to have clear-cut idea uh, whether this building is going to be demolished or it demands urgent repair, or it can be repair can be extended or can be delayed. We have some budget constraint. We don't have right now. For example, we don't have budget and we don't have some typical DPR system or the BOQ. We need some expert who can suggest us, and what is generally a rate of deterioration. A lot of the questions generally used to come from the client side, and sometimes they ask us if there's a no need of strengthening, just give me certificate this building is safe for that kind that much load for this particular time period. So all question is can't be just concluded, answer can't be concluded in one line, because we need a lot of rigorous analysis using the parameter whatever we have related to the building, from inception level, from the construction level, from design and material, and whatever the load presently imposed over the building. So if you go for the analyze the present condition of the building, so generally we categorize the whole deterioration in three categories. First is the material degradation, second is the structure failure, other is the non-structure failure. So whenever there is a material degradation, that can be also restored, and that can lead to the structure failure, up to the structure failure. Non-structure failure can be controlled by using the periodic maintenance or other suitable some external or superficial plaster or repair system. But for the structure failure, there is only two systems. One is the external support, another is the internal strengthening. So if any kind of the recommendation start with the diagnosis, first we have to diagnose any kind of structure, and agenda starts with the visual condition survey. First we go at the site, collect the photograph, prepare one diagnosis plan according to demand of pattern of distress, then various tests to indicate material degradation, cause of distresses, vulnerability analysis, residual analysis, and assessment of the structure and damage classification, and providing repair system to maintain original strength of the structure, to provide effective retrofitting and repair methodology for restore the original strength of structure, and periodic maintenance system to minimize deterioration rate of structure. And last, whatever we suggest to client on the basis of the all analysis or the back calculation or the present distress level, vulnerability indices, but they ask about the cost. If, for example, we are going to invest 1 crore rupees to restore our structure, so how long it will sustain that much load? What is the performance of repair system? And how what is the durability durability of your suggested repair techniques? So a lot of the question generally used to come on our table. So I am sharing few photographs. You can see this structure is affected with the fire but still standing. One particular column has just got damaged during the blast, but still structure is standing in this condition. You can see this structure is bombarded by the in Syria, but still some part is standing. Now this is a ruin in Pompeii in Italy. This is a standing from last 4 year, and it is externally supported by some external support system, and it can easily restrain external wind forces as well as the seismic forces. This structure is totally constructed with the mud and brick. That is an unburned brick, and it is just covered with external facade and sheet roofing. And you can say this is just protected from the external rain or the wind, so that it can withstand without any support. And second is that this structure doesn't require any kind of external support or protection or external roofing system to itself to keep in the standing condition. So this is one of under construction. This is a building under construction. You can see that a lot of the shear crack has developed here, and this is also some shear crack in wall. And this is one typical building in Mumbai, that one partially floor had collapsed, but still that was supported with the bars and bully. When upper floor, some people were already residing, so they had not vacated that place. So this and how you can see the condition of beam and how it was supported with the external by bamboo structure and wooden plank. So actually, this is the generally typical pattern. There's a lot of distress patterns. That pattern may be related with the construction or the design or the material or rate of deterioration of embedded reinforcement. And all root cause analysis can be established with the help of diagnosis system only. So for that, actually, I have prepared one flow chart, how you generally Cortex used to conclude the present health status of any structure. First, we go for the periodic visual inspection, routine maintenance. Are there sign of deterioration? If no, then there's a not to be repaired. Now, if you go for a preliminary evaluation plan, if there's a structure deterioration, so if there's a deterioration, then we go for the on-site investigation, off-site investigation. On-site investigation, we go for original design approach, environmental condition, contamination, condition of use, history of structure. And then we go for the seismic evaluation for preliminary evaluation, that is called RVS, rapid vulnerability assessment, and detailed evaluation. Then second is the condition survey and design audit study of document, distress mapping. And concluding all this, we check the behavior check. That means if there's some deflection in the beam, how it has deflected. If there's some crack, what is the pattern of crack and width of crack. If there's some similar loading in the just neighbor member, so how the particular member has, both member has behaved similar way or not. So conventional objective and performance objective, we decide along with our client. And then we go for the field test. So field test gives some, this is a one kind of the very necessary tool. On that basis, we can go for the cause analysis, cause of damage, volume of distress, damage area, interpretation of diagnosis report. And then we go for some computational or physical model analysis. If it need in terms of the seismic forces or wind forces, it is safe for the earthquake load or not, because actually NDT gives idea about only the material strength. It is not more related any kind of the this safe for the particularly load system or not. Now, if you go for the computational analysis, in computational analysis, we take the data, whatever we observe from the field. That means if presently there's a grade of concrete M20, but initially it was constructed or as per design data it is M30. But in the computational model, we'll take M20 grade of concrete only. For example, if initially there's some certain percentage of steel provided in the beam or the column, but if it has deteriorated 20%, then in the modeling will take some correction factor reduction in the steel percentage provided in the existing structure. So that way, actually, we can interpret as actual model in the present condition. So whatever it was designed earlier, it is not concern for us at present. It is more concern what is the status of building as per following observed grade of concrete, percentage of steel, present load. For example, initially it was designed for 300 kg, but now we are using for 500 kg. So in the model, we'll take the 500 kg. So that way, actually, we go for the vulnerability analysis. And if we can predict some rate of deterioration by using the corrosion sensor, as explained by the sir, that we can also use in the prediction of the residual life assessment of the any kind of structure. If following all these parameters, then we conclude these members should be urgent basis should be repaired. The repair can be global and or repair can be localized. So if there's some global repair, in that case, we have to go for the budget constraint or as per the durability constraint. On that basis, as per budget constraint, we can also provide the suggestion this repair system will last for only 5 years or 10 years. If you go for the other repair system, that will last for the 20 years or 30 years. It totally depends upon the client, how much they have budget. On that basis, we generally prepare the repair techniques and BOQ, cost analysis. And if it is required, we generally prepare the tender and financial feasibility. If a repair cost is not worthful, then demolish. We generally recommend to demolish and new structure to be built. If a repair cost is worthful, then we issue generally after the repair, we issue a structure stability certificate. That certificate is generally for the related to the performance, because we can't predict how much the another earthquake load will come, how it will be maintained, how periodically same building will be limited for that particularly load. So if we change the usage of the building, for example, here we have written, if you change the design residual service life and design life totally depends upon the intended use and the change of usage. If we'll change the use, if we change the even the environmental condition is not localized only in the weather condition. Sometimes we change for normal building into the industrial building. For example, we're using the some storage, now you are using as the caustic soda storage. So the alkalinity or the some chemical effects already surrounding concrete generally change. So rate of deterioration will be totally changed. And if you go for the some model here related to the corrosion, so generally it is a reinforcement in normal condition. If ignition of corrosion in reinforcement, we can see the some volume change. So steel has started dissipated and loss of diameter of reinforcement due to corrosion. We can see the lot of the crack will develop surrounding the main reinforcement. So one hoof stress will just push the extra force on the concrete, and after some times you can see the all the some cover will spoil and reinforcement will get exposed. So generally this is a general patterns how generally corrosion starts from the passive form into the active form. And it starts from the minor crack along the main reinforcement and last up to the exposure of the reinforcement. So this model is generally actually it is after the exposure of steel we get the panic. Then we start to investigate in terms of the chloride content or some Hobsbawm potential. They call what is the reason behind of such kind of distress. It is a chloride or permeable concrete or some moisture ingress is surrounding that. So that is a one kind of the criteria generally we are called generally after the distress has already observed at the site. But this is called the one kind of the investigation post disaster, or you can show the post distress. But whatever in the term of the sensor or some kind of the there's a lot of mathematical tools are now in the market. Just I'm sharing one report. This is one bridge, flyover in Khidirpur in Kolkata. We are doing here the dynamic analysis for the rights and HRBC. So for that, actually, we defined and that model was just in Midas. We prepared one model analysis, and then you can see here. So case 1, case 2, and case 4, and up to the 4 case we prepared. So we generally we ran a truck at different speed, 10 kilometer speed or 20 kilometer speed. In case 1, you can see here, one truck in the single lane, in the other truck in different lane, then 2 truck with the 10 kilometer speed, and in parallel 2 truck in 20 kilometer speed. So in different mode shape, to generate the different mode shape in structure, we ran truck with a different speed and with different load. So that way actually we generated the acceleration over the superstructures to see the behavior under the dynamic loading. So that dynamic loading was compared with the model analysis. In the model, if you see here, there is a model. Model gives the mode shape and natural frequency. That natural frequency was compared with the force frequency, whatever observed during the testing. So that way we concluded all the, this is our one conclusion sheet here. So if we ran at the case 1 at 10 kilometer speed, deflection under control. But in the case 6 up to 20 kilometer speed, there is excessive deflection. If you go for the vibration, so here the vibration was interpreted different way. Ghadar 1 and showing the excessive vibration, Ghadar 1 and 3 showing excessive vibration under control, vibration is under control. So actually this way actually interpreted different Ghadar system and overall superstructure, deck slab and pier structure. So we observe the vibration of different structure to by generating the external force vibration over the superstructure. After simulation with the design analysis as well as the control vibration, because that time bridge was stopped and we ran only in our vehicle in the control way, in the defined way, which way we prepared the model analysis in our Midas software. But right now, actually, the way of traffic is different from the control traffic. So for that, actually, right now we have installed our sensor at the site. You can see here, it is in running condition right now. Already installed in Khidirpur. This is a timing is at Feb 23. Right now, you can see the all the. This is a vibration is just it is coming online on our cloud software, and this software is observing vibration in 3 axes. The y-axis vertical down. You can see the x-axis. X-axis is a different pattern. And now this is the one z-axis. So it has a, so that accelerometer is 3-axis accelerometer. We can easily see the behavior of our existing structure under running traffic load. It is a horizontal movement as a vertical down and in shear plane. So that way actually we can, if any distress will come, actually we can observe the behavior with the real-time data. Real-time data means real-time loading, and if also we can put some limit value. If that vibration will cross over the limit value, then we'll get some alarm. And for that, actually, we have prepared one software. That software you can see here. For example, how generally data is interpreted. If this is a core value, so you can see here core is the totally histogram, and this is a normal distribution curve. This is a generally histogram, and this is a bell-shaped curve. So you have to how much percentage sample you have to reject. that will generally decided by the statistics analysis, and how much the error is in your data collection, that is also generated from the statistics analysis. And from pie chart you can get the easily how much the percentage of grade of concrete is M30 to M40, M25 to M30, above M40 and M30 to M35, and how much sample has how much samples have fall in this category, the 7 or 2 or the 1 or 2. That will can easily, if you have to increase the number in that particular category, then it may change in the behavior in our histogram or the pattern of histogram or the bell-shaped curve. So actually data is very important. Generally data is collected by the some technician or skilled person, but from where data should be collected, how data should be stored, and how data is analyzed, it is a very important topic, and that should be generally done by the some analytical tool. So one is the qualitative analysis, one is the quantitative analysis. The lot of labs are doing the qualitative quantitative analysis, but now the qualitative analysis is very important, and that error can be minimized by using the sensor data only, because your software and algorithm will be always neutral, that will not bias. But yes, your person or your information or your data collection might have the lot of error in that system. That should be improved. If you will minimize the all and come in the simulation way, if you start to job with the different mechanism. For example, if you go for the rebound hammer test in the 5 damage area, you get the higher result because there's some kind of carbonation effect. But if you go for the USPB, it will be very doubtful condition because the surface microstructure crack. So how will interpret the data? That is generally it comes through the general study or the some exposure or some experience or the lot of interpretation. If you have a lot of interpretation, you have developed the tool, because one test can be certified with the other test can be certified with another test. The lot of the other system may have the different error percentage in one case, and whoever the accurate test that have more the error percentage in that particular case. That comes with the behavior of the structure. If you understand the behavior of the structure, then you can easily interpret the data, and that interpretation should come by the help of the some structural consultant or the some who has done some lot of the research in this area. And on that basis, actually we should start to collect the sample at the site. If you will do this way, then we can have the more information. For example, just we are also one bar chart I'm putting here. So if you go for the comparative analysis, for example, here, level 1, code 1, for example, this one, and the M20 is the before grouting, before grouting. No, code 1 after grouting, for example, M30. Now I'm coming on the code 2 before grouting, 40. Now, if you go for the compare analysis, comparison, you can see here that this is a comparison. So how the data is generally changed. So data has changed. If you go for the minimum, for example, minimum grade of concrete should be M15, maximum should be M40, average should be at least M20 after the repair or after the grouting. Graph name is the sample condition, y-axis is the MPA or something, y-axis name is the grade, and before verify the grouting and after grouting. So you can see here the how actually our statistics analysis gives the how much sample is lying above the average, below the average, and below the threshold value, above the our maximum expected maximum expected design value after the grout. So this way actually we can interpret the data more accurate way. Even we can control our repair system. We can monitor the execution quality job at the site, and then we can come on the guidelines. Guidelines should be always changed with the just with the type of the machine or the equipment comes in the market, or the sensor type comes in the accuracy, and how whoever the using the same kind of technique in the field. So all will be simulated at the together. Then only we can give the perfect consultancy, and we can conclude the perfect with the present health condition of the existing structure. So this is my whole theory. Hello.
Okay.
So, sir, this is a one final presentation. Actually, for that, I have developed one app, and so any person can go at the site, and by using the Android app, they can collect information from the different sites, and that same in real time, that information will become our cloud system, and that interpretation will become in real time. Any expert from in his office can easily see the how data are being collected, and these data can be used in the interpretation or not, and that way actually we can minimize the error in our consultancy. Okay, thank you.
Thank you, sir, for your informative presentation. National Institute of Disaster Management and Civil Engineering and Construction Review presents Certificate of Appreciation to Mr. Manish Bharti for the expert lecture on online certification and assessment of building health during the 3 days online training program on infrastructure health mapping standards and retrofitting of built-up facilities from 23rd to 25th February 2022.
I would now like to request Dr. Chandan Ghosh to start with the panel discussion. Over to you, sir.
Okay. So three presentations, and I was requesting all the participants on the chat box to send their queries, but they are so much enamored by the presentation that probably they are forgetting that they have to ask question also. Probably they are so much enthusiastic. Everybody is thanking, and very good presentation and nice way of CE&CR's presentation structure and methodically, systematically. So all appreciations are there in the chat box, which you all can see. What is there now? It is open. Please, you write your question. One question I can see that to Manish, written by Manish Ramesh Kumar in the chat box. If drawing for old RCC structures are not available, are there any way or methods which existing enforcement in the old existing structure can be determined? It is very relevant and good question by Ramesh Chaudhary. And
Yes,
Manish?
it can be done by using hand GPR as well as the profometer is one equipment that works on the principle of magnetic field. So, but it has one limitation to detect up to only 50 mm or 80 mm. But if you want to detect reinforcement, double layer reinforcement, in that case, you have to go for the GPR.
Yeah, very high frequency GPR.
Yes, yes.
Ray bar scanner or profometer is there, but
yes.
Okay. And as-built drawing also can be made these days using 3D laser scanner.
Yes, laser scanner.
Both inside and outside, they do the mapping.
Cedar or something.
Yeah.
Basically, impulse radar can give you some idea about even layers of reinforcement. But you know, in India, mostly it is profometer, which is very popular.
Yeah.
Apparently, maybe Manish is using radar.
Yes, sir. I have one GPR. Yes.
GPR. Okay. GPR can go even high frequency. GPR can go even entire wall, maybe 40, 50, 60 centimeter also. Is it true and true?
Sir, generally, its accuracy is limited up to 300 mm.
Okay. Yeah. Okay. Then another one to everyone, sir. Will building information management solutions accentuate our effort in regard for retrofitting? Okay. So to everyone means, I think,
building information management
or Professor Bhattacharjee.
Building management information, what is that?
It is building information management, I think.
Building information modeling, it is.
Modeling.
Building information
BIM,
modeling.
BIM, that is BIM.
BIM. It is not.
BIM. Yeah, building information modeling. That's actually, no, that starts, it has got a lot of features actually. It starts with Revit or some other ones to actually get a 3D view of the whole thing, 3D details of the whole thing, followed up by you can have progress of the project and things like that. Even retrofitting, you can use it if you like, that what is the existing, but then you have to have structural design integrated with it actually. That also perhaps can be done. So if you know what is the current structural situation, retrofitting, how it will progress, that one can find out. Building information modeling, that's what it is, yes. BIM is used by most of the construction companies, top level construction companies these days. L&T and all that, they are using it.
Yeah. Dr. Sunny, you want to say something?
Nice. I think we had good presentation from all three experts, and I think this is the high time that we should ask questions from our engineering fraternity rather, because you started the presentation with Gurugram or Gurgaon building, and then whether we can sustain really such type of structures in the country, or then who will own the responsibility of such a structure, and even somebody is made responsible who will pay for the retrofitting. After all, this is taxpayers' money. So unless this comes and these questions are directly on the persons who are responsible for that, the quality cannot be improved. So important is that sometimes I'm sure that even FIR will be lost sometime, someday, and whosoever the engineers or whatever they are supervisors, they will someday they will go to jail. So it is the high time that we give importance to the quality and specifications, which we are not giving. It is not government or private. Everybody has to give. Now the government is not constructing those many buildings or structures what private builders are doing. They are more in numbers, and we in personal capacity we are depending on them. So it's not only that we are depending on government. After retirement also government officers will go to private buildings. So quality has become very important. And then Professor Bhattacharjee also mentioned about corrosion. And now why corrosion is coming so early? That is the question. So it's again the problem of quality. And then we go on justifying the cost. We go justifying the cost of rehabilitation, retrofitting, repair, and everything. And still we can never achieve the same life of the structure as Mr. Bharti was telling, that whatever the life of the structure is planned, that useful life, you call it economic life, you call it, or life of the structure, you call it, that cannot be achieved with the rehabilitation and retrofitting. Let me tell you, because once corrosion has gone, cancer has gone in the RCC, then it is very difficult to remove the cancer, like in the body. As Mr. Bhattacharjee started with the body, human body is the same thing with the building. And sometimes I say that buildings are weeping, not properly maintained. दूर से देखने से लगता है कि बुरा हाल है उनका. They are not properly maintained. They probably abuse to we engineers, that you are not maintaining, you are not doing what you should do, or you are not done in the past. And there is no substitute of bad planning. And if bad planning is there, then it is going to be very costly during retrofitting. So I always insist that first thing is that please do not think for retrofitting. First think for the quality construction. That is important. And if you have not done, then there is a problem. Probably retrofitting, what we are talking, what we have discussed is today, or even we will be discussing. Retrofitting should only be there when the codes have been revised, designs have been revised, and we need retrofitting because of the strengthening of structure. But what we are discussing is probably rehabilitation, that we have not done what we should have done it. So that is the problem. And what are all the engineers, whether they are 90 or 95 or 100, please take care that the buildings or other structure, road, anything, whatever you are responsible for designing or construction, please do as per the requirement. That is our aim, that is our ethics. And if you are really doing that, then we are really doing the great job for the country and for the nation. Thank you.
Yeah. Thank you very much, Dr. Soni, for sharing your overall comments and suggestions and concern, as well as for the building information mapping and trace and the industry that who are involved.
And so there is one, because you know better than me, 13935, that is rapid appraisal of performa given, has been given. So anybody who is interested, please download that code 13935. It is basically for masonry structures, but it's good for rapid appraisal, and a lot of performa have been given, and one can use them.
Yeah.
In fact, the number of structures that I have investigated over right from 1990s to till date, in fact, 95% of them are river corrosion, and that to internal chloride.
Okay.
It is buildings I'm talking about.
Mm-hmm.
Now, which means that we should make it mandatory in the code that the cube should be crushed. When you have crushed the cube, take the samples and do a chemical test for chloride.
Yeah.
The most of the cases, what happens is sometimes it goes unseen. I mean, people have used bad concrete, but since the moisture was not there, corrosion didn't come by. But once the quality of construction is so bad that concrete is also porous, and the water is logging because your slope in the slope in the washroom, bathroom, is just the opposite direction of the trap. That's usually the kind of quality of construction we see in buildings many times. The trap is here, slope is just other around, so the water stagnates. Now, when water stagnates and your quality of construction is so poor, the invariably moisture will enter into the concrete, and if chloride is also there in the right in the beginning, 7-8 years, people have, I mean, first time I came across a building, people came to me after 5 years in Dwarka area.
Yeah.
Sir, I will tell you the example. I'll tell you the. See, you might have seen number of buildings in Kolkata. You will not see seepage in the bathroom, and you will see even Kerala. You will not see seepage and leakage in the bathroom, but you see it in Delhi. You will see them.
Yeah, that's right. That's I'm surprised.
So it's not surprise. I know what is the problem. Problem is that we don't do smoke test. What you are saying, trap is there, then people will, oh, आएगा कोई भी थोड़ा सा लगाया जाएगा, and nobody is supervising. And then nobody is doing the testing. So that is the problem.
Yes.
So this has to go right up to the plumber, mason, and carpenter. That quality work is to be
No,
done.
even building certification.
Yes.
Building certification.
सर सर्टिफिकेशन भी हो जाएगा, क्यूब भी हो जाएगा, unless everybody is responsible कि जो है हाँ सही करना है. Problem is this.
ना ना, बट वो ह्यूमन बीइंग को आप बहुत ज्यादा चेंज नहीं कर सकते, लेकिन लिख के दे कि भैया हमने ये सारे टेस्ट किया है. इट शुड बी ऑन ब्लैक एंड व्हाइट रिकॉर्ड में होना चाहिए, कल को पकड़ सकते हैं. बट आज वी आर नॉट इवन लुकिंग एट, एक्सेप्ट क्यूब स्ट्रेंथ वी डोंट लुक एट एनीथिंग. You look at cube strength and maybe steel, etc. Even where it is looked into. But that's the psychological problem also. Mechanized होगा तो थोड़ा बहुत improve होगा, but RMC plant में भी ये problem है.
Human beings are there, sir. Unless you fix responsibility at every place, it is very difficult.
Yeah, as rightly shared, I think one of the difference, like Dr. Soni have mentioned about in Delhi or Gurgaon, like whatever we have seen, in why it is happening, because here extreme weather is there. Extreme weather means we do not generally, code doesn't say anything about that during, like if we are doing some kind of building construction or repair work in the month of December, January or February, and then the kind of curing that takes place. And if same construction is being taken up in the month of May, June, and curing part of the things of the which is hardly taken care by any construction agency or anyone in the quality. So cracks automatically are there in the during curing phase itself. And when raining is there, water is entering, and then continuously it is happening.
Sir, what you have shown the slide of Gurgaon, that is not curing cracks. And let me tell you that we are not curing cracks की तो बात ही नहीं कर रहे हैं. We are talking about the structural cracks.
Yeah.
And structural strength of the concrete. Mr. Bhattacharjee is telling actually the strength of the concrete. Concrete is poor. That he has done the test from the test. He has done the test, but even without testing, also he will tell that concrete is poor. That is the problem.
Yeah.
Like curing is the least attended or even in, even in engineered construction, because it is a, your contract goes as concreting per meter cube or per, ton or whatever it is. Price, the what do you call item rate goes that way. And curing is included in that. So normally, if it is manual curing, out of all the labor force, out of all the workforce, basically, the one who's most redundant, but उनको रखना है किसी तरह, तो उसको क्यूरिंग में लगा दो. वो थोड़ा टाइम पानी तो पटा देगा, लेकिन उसके बाद बीड़ी पिएगा, गीला हो या सूखा है, he is not bothered or she is not bothered. I don't know whether it is changed, but this is talking from my own side, obviously in 78, 79. In a big construction company. But then today you have other solutions. You have curing compounds, and you have, you can, if it is precast, then you can have a fogging. Several solutions are there. But main problem वही है, construction quality पे हमारा मतलब ये जा नहीं रहा है.
Yeah.
It's not going to this.
Yeah. And now, in fact, we have shifted very fast into digital construction, and supervision is going on. Maybe some construction is going on in Kerala, and the mobile app is here. Someone is maybe in Kashmir, supervising that whether concreting has been done to this level or not. And after concreting done, put the drone and drone say every inch, whatever target was there is being checked or not. Now it has gone to that extent that one person, maybe he is the supervising digitally, maybe 100 sites at the same time, and getting all these parameters take into the mobile or into the spreadsheet and giving a full things that without visiting the site or without looking at that. So that part also has taken a rot into our quality conscious say supervision, that which is missing, because everything we are shifting towards data and analysis, and then put everything into the spreadsheet. And also these days, even soil investigation, when it goes on in the hilly area or some tunnel construction, soil investigation up to 40 meter, 50 meter, they do the investigation automatically. All data, all parameters or empirical formula are there, where it is giving every SPT and everything. They are giving interpretation in a spreadsheet coming up, because all formula, empirical formula without site condition taking into mind, it is all fill up all those bore log and everything automatic, it comes into that. So it is also very much too much of data, too much of data which are arranged and segregated. And then when we really go into the site, taking this data into mind, as well as checking something physically there, is a really very, very complex and very, very difficult for an experienced engineer also. While seeing so many data, so many curves, so many diagrams, so many cube test report, and then relating them together, integrating the result on site is really very difficult.
Actually, Dr. Saab, problem है कि जो what we are doing, that even say geotech investigation we are doing sampling only. It's say for the area of say 10 meter, say 25 meter by 25 meter, one bore log has been done, borehole has been done. Then my foundation may come somewhere else.
Yeah.
And that data will not match at all. So when we do work at site, then it is very important that whether that is matching or not. If it is not matching, then it will certainly
useless.
be entirely different. So that is what we are saying, that the implementation authority or site engineers have a great role. It's not that they just take something and even in designer will assume only one or two bearing capacity. He will not assume 10 bearing capacity for 10 locations. So that is to be seen. So that interpretation, what you were telling, or Bharti was telling, interpretation is important for designer also, for the investigation agency also, for site engineer also, for everybody. Interpretation, data is a lot of data is available, but then interpretation is the most important.
Yeah. So I think it is about to be 6 o'clock on dot, and I would say that we are really, I think there are not many, but pre-check and post-check are very important to maintain. Yes, we are echoing the same thing. I think Milind Valirao is telling. Okay, then it is time when maturity-based strength correlation should be followed. I think we are also speaking in the same line that as Suresh Tripathi ji has been mentioning in the chat box. Okay. Oh, there is a question for me. Sir, NIDM is doing any public awareness campaign about the risk involved using inferior quality material. In fact, our training programs, we do in this manner only for awareness sake only. Inferior quality material, and we have very, very wide level of awareness program. So you are most welcome to visit our NIDM website, and many such programs are going on. And so you can see that our activity in that way. And in fact, whenever we do retrofitting related program or rapid visual screening, or even bioengineering by vertical graphs, when we do, or even many other programs, resilient infrastructure. Of course, we do not go into that much detail, but awareness part is our main aim. Awareness and community participation across the country, and we conduct several such awareness-related programs. We visit the site, take our participants to the site, and then have their view and their, whatever is being discussed during training program or during workshop, it is they are taken to the site. Like next week, we are going to State Disaster Management Authority in Shillong, Meghalaya. So there 3 days engineers program will be there. So it is a residential one. So I'm going there. So it will be full day visit. First day introduction. Second day will be ongoing site visit. Third day will be their experience sharing. So in 3 days time, we do only this much. And we call all the contractors and all the architects and all the engineers all together and city planners together, and also experienced engineer. There in the many professional organizations we call as our expert speaker. So, okay, I think without much, I think for 3 hours we are here online, and on behalf of NIDM and Civil Engineering and Construction Review, we would like to thank, of course, I know thanking is not enough, but the kind of warmth that you have shown to this online program, that it is marvelous, and I hope that all the participants have taken it to their heart and getting more enthusiastic for tomorrow and day after tomorrow's program. And so now
Thank
it
you,
is
sir.
to CE&CR.
I'm making an announcement for all the registrants, participants. If you wish to receive an e-certificate for attending this training program, kindly register yourself in NIDM's portal. Please visit training.nidm.gov.in. Once again, thank you all for attending today's session. Hope to see you tomorrow at the same time, that is 3 p.m.
Okay.
Thank you.
Thank you, sir.
Thank you,
Thank
sir.
you. Thank you,
So,
everybody. Thanks.
thank you.
Thanks.
So it will be taking 2 hours time. Otherwise, I would have taken tea with you on the Alkananda market.
No, it's okay. It's all right. We'll do it sometime.
Let us reserve it for weekend.
Yeah, yeah. Sometime, yes. Okay.
Okay.
Okay, then, right. Goodbye.
Okay, Sunny sir.
Thank you very much. Thanks, everybody.
Yeah, thank you. Manish is there. Excellent presentation, Manish. Yeah. Okay.
Right. Okay.
Okay.